Hello everyone. Today we are going to deal this problem with Green's theorem. So first I will read the problem, then I will explain the concept step by step. Verify Green's theorem for a single integral and its vector. Then where C is the closed curve of x square is equal to y and y square is equal to x. So this is the problem where we want to verify the Green's theorem. Okay, now to verify the Green's theorem, let's come to step 2. This is the statement of Green's theorem. So what is saying in the statement of Green's theorem that we have discussed in our last problem itself? So we have right hand side and left hand side in the statement. So in left hand side, we are going to find out area by help of some information which will be collected in the boundary line, and also at the same time on the other hand we are going to find out the area by help of the surface integral. Okay, now let us see both answers are equal or not. Okay, now let's dive into the concept in step 1. Okay, in step 1 we have to draw the diagram first for the given information. This is the given information, understand that. So here we have two parabola. This is x square is equal to y and y square is equal to x. First we need to draw the diagram for this given parabola. So always take x-axis and y-axis. So x square is equal to y is a parabola towards y-axis, and y square is equal to x is a parabola towards x-axis. After drawing both parabola, now find out which is the common area that where you want to find out the area. This is the common region, right? So here you need to find out the area. So this is boundary line. Okay, this is boundary line and this is the surface of the area. Understand that? Surface of the region. So you are going to find out area by this surface region. Okay, and also you are going to find out area by help of this boundary line. So both answers should be equal. That is the Green's theorem. Okay, now for this we need some information from this diagram. We need this point and this point, and what is the name of this curve, what is the name of this curve. So already these two curve has given in the question itself. Okay, so we know very well this curve and this curve, and also obviously this point is 0 comma 0. So we need to know only what about this point, that can be easily get. So you just write both the curve equation, that is equation number 1 and equation number 2. You can substitute any one equation in the another one. From this by deriving this part, you can get what is y and what is y and x. Okay, now you have x equal to 0 and y is equal x equal to 0 and 1. Similarly y is equal to, when you substitute x equal to 0, then y is equal to 0 in this any one of this equation. When we substitute x equal to 1 in any one of this equation, then y is also 1. Therefore 0 comma 0 is here, 1 comma 1 is here. So after collecting all these information, then you have to plot all these information in the particular places. Now let's come to here. So we need to find out what is the x limit and y limits. Always x limits here will be the variable limits, because as per the formula we have dx first. If we have dx first, then you have to write here x limit here. Okay, so always if we have constant limit and the variable limits, so variable limits has to be written only in the inner integration. So this part is going to be the inner integration. So where we have to write out x limit. So now let's see how I am getting the limits. This is very important part in this problem. So if we have dx first, then you have to draw a strip towards x-axis. Okay, from this strip you are going to collect the limit points. Okay, the strip will touch two lines. Definitely the strip will touch two lines. So from these two lines you can get any one limits, right? So what about this bottom curve? This is top curve according to the strip. Okay, in your bottom curve you have to get x limit, it is x equal to y square. In top line also you have to get x limit, x equal to root y. Therefore, x varies from y square to root y. Similarly, now you have to move the strip towards this side, then towards this side. When you move from left to right, you will get what is y limit. So here y limit is 0, y limit is 1. This is the way how to find the limits. After finding the limits, you just write it here. Let's come to step 2. In step 2, you have to write the Green's theorem formula. And also, you need to find out what is M and what is N. Understand that? So this is the Green's theorem formula. So now I'm going to find out what is M and what is N from the question. Understand that? So always in Green's theorem we will be given with the line integral. Okay, our formula this is the general formula for line integral. So what is the in this general formula? M dx plus n dy. So here also m dx plus n dy. So this part is called m. This part is called n. Now is just write what is m and what is n here. From these two information, you have to find out what is from m. You need to differentiate with respect to y. From n, you need to differentiate with respect to x. So both I have done here. So that is this one is my answer after differentiating with respect to y and x according to my formula. Okay. Now let's come to step 3. In step 3, we are going to find out the area by help of the surface integral first. That is right hand side. So first right hand side, what do you have in your formula? You just write that. So this is my formula. So now I'm going to replace my information which I have got here, right? So I'm just going to write replace dou n by dou x by its value. Then similarly dou m by dou y by its value. After replacing, you will get. Once you started replacing this information, you have to write your limit also. So first dx limit. So already you have collected your limit also. X limit is y square to root y. Similarly, y limit 0 to y. Now, one more thing you have to understand in double integration or integration, always this lower limit, this is upper limit. Understand that? So always we should have the smaller value in the lower limit and the higher value in the upper limit. But here it is in the opposite, right? So we have to swap our limits. When we swap our limits, what we have to do? We have to add a minus. This is limit per integrate. When you are changing, when you are swapping your limit, you have to add a minus here. This is integral property. Understand that? So by help of property, I have swapped my limits from here to here. Now look at here. It is root y. It is y square. Understand that? So now here we have the smallest value. Here we have the highest value. Okay. Now it satisfies the rule. Let's start integrating as usual. So first we need to integrate with respect to x. So when you integrate with respect to x, your answer is 10xy because here y is constant. So 10xy. Now substitute your limits, upper limits and lower limits in x. Then this will become like this. Understand that? Now after substituting, now integrate with respect to y. So when you integrate with respect to y, it is y power 4 divided by 4. It is plus 1. Then 10y power 5 by 2 divided by 5 by 2. Now substitute your upper limit and lower limit. After this is very normal simplification. Then your answer is 3 by 2. In the right hand side, you got the area for this region is 3 by 2. Now what you have to do? You have to find out the area by help of the line integral. There also you should get the area is 3 by 2. Understand that? Let's see how it works. Okay, first left hand side. Okay, what do you have in the formula left hand side? It is integral over c m dx plus n dy. I have directly written what is my m dx plus n dy. So this is my left hand side. So now here what I'm going to do, let's come to the diagram. So in RHS, we have found the area by help of the surface, this surface. Okay, in LHS, we are going to find out the area by help of this boundary line. So that means I'm going to name this point and this point. This is in the name of O. This is named as A. Okay, first I'm going to measure some values in this boundary line. So this is OA. So along OA plus, then let's come to from this point to this point AO. So this closed region C can be separated into two lines, two boundary lines, that is OA plus AO. This is suppose if we have number of lines that will be closed, okay, you can write in this term, that is the first OA plus AO. The last in last line you can write what is the given expressions. Okay, this is allowed. Now after writing this, now let's walk towards OA. Along OA, what is the equation that you have? It is y is equal to x square. Understand that? Let's see in the picture. So in the diagram, you can get along OA y is equal to x square. From this, you have to differentiate your y with respect to x. Then this will become dy by dx is equal to 2x. Now transform dx dy is equal to 2x into dx, right? Now substitute these information in your OA and its corresponding vector value, that is this one. So now instead of y, I'm going to replace by x square because so look at the formula. In the formula, we have single integral, but our integrating derivative is dx and dy. So we can't integrate with respect to two variable in single integral. So what we have to do? We have to convert this two variable into the single variable. For this purpose, we are doing all these process. Now, if you substitute all these information in your vector values, then this will be converted into single variable. So I'm going to substitute y is equal to x square. Wherever I have y, here I have y. So this will become y power 4. This will become x power 8x power 4. Then plus symbol then plus 4y, here we have y, it is a 4x square minus then 8xy, y means x square, then it is 8x cube, then dx is nothing but it is 2x into dx. Now you just simplify it again, so 3x square 8x power 4, then here what will come? So you just multiply this 2x into this value, then what this will become 8x cube, then minus 12x power 4. So now you can integrate. Now look at this. So it has been converted into single variable. That means all the variables are in terms of x. Now you can use single integral. So by using single integral concept, you can integrate it. Now after integrating, your answer is minus 1. Now we need to find out what is the value. What is the value along AO? Now along AO, right? So now from this point to this point, this boundary line that you are going to measure. So along AO, what is the equation you have? So this is the curve. This name of this curve is x equal to y square. So I have written x equal to y square. From this equation, I need some information that I'm going to differentiate this x with respect to y. Okay, this will become dx by dy is equal to 2y. So when you take cross multiplication, dx is equal to 2y into dy, right? Now you have to substitute this information, right? This information in your AO, okay, single integral line of AO. Therefore, AO and its AO and its vector value, right? So you have to replace x by y square. Here we have x. So y square the whole square. It is y square the whole square. That's equal to y power 4. So 3y power 4 minus 8y square. Then dx can be written as 2y into dy. Then plus 4 times y. Then minus 6. X is what here? It is y square. Y square into y is y cube into dy. Now this time you're going to simplify it again. So I'm going to multiply this 2y into dy into this one. then this will become 6y power 5 minus 16y cube plus 4y minus 6y cube into dy. Now you can integrate this one with respect to dy, right? So when you integrate with respect to dy, 6y power 6 divided by 6 minus 16y power 4 divided by 4 and 4y square divided by 2 minus 6y power 4 divided by 4. Now cancel the common terms and substitute upper limit and lower limit. Upper limit is 0, so everything will be 0. Then lower limit is 1, so you can get value only in the lower limit. So when you substitute the lower limit, you have to add a minus here. So this is the minus. Now 1 minus 4 minus plus 2 minus 3 by 2. Simplify it, 5 by 2. Now you have got both lines. So you have got O to A and A to O. Now what is your next step? You have to add these two information. Okay, right? What you have got in OA, it is minus 1. Okay. Now what you got in AO, it is 5 by 2. So now both answers, if we add both answers, it is 3 by 2. Therefore, the closed curve, okay, the closed curve has been separated into two lines. Okay, the first line OA plus second line AO. So I'm just calculating these two lines individually, and at the end I'm adding these two lines value. That is my area. Understand? When I'm calculating by help of the closed curve. Okay. Now what is the answer? Is 3 by 2. So what we have got in right hand side, there also we have got 3 by 2. So both the answers are equal. Therefore, RHS is equal to LHS. Therefore, verify Green's theorem. Verify Green's theorem. Okay. So thank you so much. If you have any doubt in derivation part, you can text me in the chat box. I will help you. Thank you.